Okay, welcome to section 2.6, day 2, part 2. All right, so in the previous video, we talked about when you have a parent function like x squared, to make it stretch, you can just multiply it by like a number that's more than 1 there. Or to make it compress, you just multiply by a number that is between 0 and 1. So something like 1/4 would make the parent compress. This video is going to be about how to make it reflect. There's two different possibilities we're going to cover, which is reflecting over the x-axis. So if you look here, this black parent function, kind of a weird function, but we want to make it flip over x, so there's one way to do that. And there's also a way to make it flip over the y-axis. So as an example, this black one, if you flipped it over y, it would end up over here in this green one. Okay, and so the confusing part is the way we do it is actually also to multiply. So that multiply, they called it A, made it stretch and compress in the previous video, but you can also make it reflect. All right, so that is the lesson for today. And again, I'm going to encourage us to start with that Desmos program and sort of play around with it. All right, so what we have up here is, right now I have showing x squared and then the 3 that makes it stretch. All right, so take a guess. Any idea how you're going to make it reflect? How could we change this 3 to make it reflect? All right, and after you've thought about that for a minute, the answer is you actually just make it negative. So if we put a negative in front of it, you'll see that it flips over the x-axis. All right, and so you can do this with any function. So I'm going to take the one down here. All right, I'm going to graph it originally. And so it's just moved to the left 5 because of the plus 5. And then if we make it want to flip over the x, we just put a -1 in front. So I call this multiplying the whole thing by -1, and that'll make it flip over the x-axis. All right. So the goofy part is, and we'll get this all in our notes in a second, is that over the x-axis you do the whole thing times -1. All right, but I'm going to do that function again here, x plus 5 squared. Right? So that's again going left 5. So to make it go over the y-axis is goofy. So for x-axis, the -1 takes the whole thing times -1 to make it go over x, like is shown here. But to make it go over y, maybe I'll leave that one up there and do one where it goes over y. All right. So if I want to make this thing go over the y-axis, I just put a -1 inside with x. Right, so you can see that if I put the -1 inside with x, it flips over the y-axis. So this example went left 5 because of the plus 5, and then this negative makes it go over the y. Okay, so a long story short is, to make it go over the x-axis, you take the whole thing times -1. To make it go over the y-axis, I can show that's kind of where we started again. We went left 5. To make it go over the y-axis, then you take just the x part times -1. So the blue one goes left 5, and then when you slap the -1 in front, it flips it over here over the y-axis. All right, so let's get all that down in our notes to make sure that that's clear. So to reflect over the x-axis, you multiply the entire f of x function, all the outputs by -1. All right, so in the example here again, the original function there on the left went left 5, and then the one on the right went left 5 and then would reflect over the x-axis. All right, and again, that's because the -1 is on the outside. All right, so where the negative goes is really significant. All right, so pause it here and get this down if you don't already have it. All right, so it reflects over the y-axis now. So to do that, you multiply just the x part by -1. Okay, so again, here's the one we were messing around with where that went left 5. And then this -1 will make it go, actually goes left 5 first, and then it reflects over y-axis. Okay, so again, get this down with some examples here before we move on. The rest of this lesson is just some questions, practice questions. Okay, So first one is we're going to start off with a little bit different parent function. This is a linear function, just with a slope of 3 and a y-intercept of 3. But we want to make it reflect over the y-axis, right? And so you just got to think, okay, let's look back. And according to the notes, to over the y-axis, you multiply just x by -1. Okay, so what happens here is we take just this x part times -1. Okay, so we're going to call our new function g of x, and we're going to say that that equals to, if we take just the front part times -1, we get -3x plus 3. Okay, versus the second thing is same original function, just go over the x-axis. And according to the previous information, to go over the x-axis, we have to take all of this times -1. Sorry that brace didn't turn out very smooth there, but we're going to take the whole thing times -1, call the new function h, according to the directions here, and so we'd get -3x minus 3. So in this case, we have all of it times -1, and so it looks like that. Okay. So I'm going to see if you can put all this together, right? So this example says we're going to start with f of x that is equal to a little bit different parent function. It's a linear one with a slope of 4. But then we want to do these different transformations. We want to compress it by factor 1/2 and then reflect over the y-axis. So again, I'd pause the video, try it, and then I'll go through an explanation. Okay, so the trick is we're just going to go step by step here. So I'm going to compress by 1/2 first. All right, so we talked about before, compression is just multiplying by whatever value we have. So to compress it by 1/2, we're just going to multiply it by 1/2. So we get 2x. Sorry, my computer is struggling here a little bit. We get 2x. Okay, and then the next part is to reflect over y-axis. Okay, and to do that, you take just the x part times -1. And we only really have an x part here, so it's kind of weird, but we just take that part times -1. So our final answer, g of x, is just -2x. Okay, we took this parent, performed some transformations, and that's what we ended up with. All right. So f of x equals x, a straight linear one again. Stretch vertical factor of 2 and then go down 3 units. Again, pause, give it a shot. All right, here we go. So f of x is starting off as just basic x, and I want to stretch, sorry, I messed that up, stretch by 2. So just multiply it all by 2. So our new function, calling it g of x, equals 2x. And then after that, we want to go down 3. So for down 3, you just slap a -3 on the end. So our final answer here, 2x minus 3. Okay, last type of question is slightly different. It gives you the starting function, which is f of x equals 2 times x squared. We have to get it to this g of x, which has a 6 here now and a -1 here. So it says, like, what kind of transformations do we have to do? So it's kind of the reverse of what we were just doing, right? They're giving us the starting and the ending point. We have to fill in what goes over here for these transformations. All right, so again, I would just do it step by step. So I know I need a 6 here, right? So if I originally have f of x equals 2x squared, I can just kind of think, what do I got to do to get a 6 there? All right, and so hopefully we can figure out that that is a stretch by 3, right? Because then I can multiply. If I do a stretch of 3, that's going to multiply this by 3 and yield f of x equals 6x squared. Okay, and so now we're almost to what we want. I guess I just start calling this g of x to match the problem because we're changing the parent, which was f. So g of x, I have now 6x squared. And then to make it have a minus 1 there, we just have to go down 1, and then we'll end up with a minus 1 in our equation. So we end up with 6x squared minus 1. So this is really the answer. These are the transformations we need to do to get from 2x squared to 6x squared minus 1. Okay,